Hello, this is Dr. Yamada. In this video, I'm going to talk about how to calculate an absolute joint angle. So before we begin, I'll quickly go over the difference between absolute and relative angle. So absolute angle is the angle between a body segment and a fixed line. So the angle between a body segment and an imaginary fixed line. So usually it's relative to the horizontal or vertical line. So in this case, for the hip, absolute angle is between this and this. So over here. And for the knee, absolute angle would be between this and this line. So the angle over here. On the other hand, relative angle is the angle between two body segments. So usually it's a range of motion, right? So the angle between this body segment and the thigh body segment, so the obtaining angle between this is the relative angle. Between the femur and tibia, the obtaining angle between these two body segments is the relative angle. Okay, so in this video, I'm going to focus just on the absolute angle. So if I magnify this arm, right, and then imagine that you have actually captured the shoulder and elbow and wrist markers of this person running, and then we take a snapshot of it. So this is a shoulder marker, elbow, wrist, and this line indicates the upper arm, and this line indicates the forearm. Okay, so here is the x and y coordinate of the shoulder marker, and x and y coordinate of the elbow marker, 45 and 110, and x and y coordinate of the wrist marker, which is 22 and 70. So imagine you want to obtain the absolute angle of your arm, okay, the elbow. So in this case, you can draw a horizontal line, fixed line, right? And what you want to obtain is the angle over here. And if you draw an additional vertical line, which is depicted in the red dotted line, now you can actually create a right triangle. And once you can create a right triangle, you just use a trig function to obtain this angle, right? And eventually, what you need to do is you want to obtain this angle. You know that this angle is 180. Therefore, what you have to do is after solving for this angle, then you just need to do 180 minus the solved angle. Okay, how do we do that? We want to obtain the length here and length here. So imagine that you have a flashlight and you put a flashlight towards the wall of the x-axis, right? Then you can imagine that there will be a shadow of this shoulder marker and elbow marker, like this and like this. If you can imagine this way, then the length between these two data points, shoulder and elbow marker, is exactly the same as the length of this right triangle. So, which happens to be the number between 45 and 36. So what you need to do is just obtain the difference between the x coordinate of the two joint markers, which in this case, 9. And you do the same thing for the y-axis. So imagine you put a flashlight from the right side, and then you can get the shadow of the shoulder and elbow marker like this and like this. And the distance between the two markers is identical to the distance between these y coordinates. Therefore, obtain the difference between the two data points, which in this case is 55. So now that we have obtained the length of this right triangle, so when you think about this, the angle you want to obtain is over here. Therefore, 55 over here would be the opposite side, and 9 over here is the adjacent if you know the opposite and adjacent, you can use arctangent or inverse of tangent, right? Which is the ratio between the opposite and adjacent. The number you will obtain after this calculation is the angle in radians. So after you obtain 55 over 9, you can convert it to degrees, which is in this example 80.7067. So in the end, you want to observe this angle. So 180 minus this answer, which is 99.29 degrees, is the absolute angle at the elbow joint. If you want to calculate the other absolute angle, you can use the same logic. So for example, you want to obtain the knee absolute angle, right? So if I magnify these three data points onto XY coordinates like this, right? You want to obtain angle between the segment and a fixed line. So the theta over here, and you do the exact same thing. One thing I want you to understand here is that you do not need to do 180 minus theta because this is the angle you wanted to observe, right? So in the previous example, you are obtaining the other side of 180 degrees, right? So, but you wanted this one. So that's why you had to do 180 minus whatever you obtained.